Welcome back. In this video, we are going to create our first Spark streaming application. So let's start. Let me define the problem and then I'll create a solution for the same. We want to create a streaming word count. In fact, I'm going to create the same example that is given in the Spark documentation. You can get the details here. Great. Reading a text stream and counting words is an excellent example to start with. This example might not make a lot of practical sense, but it can help you get the first sense of how Spark streaming works in Apache Spark. So here is the pictorial representation of what we are going to do. We will start a Netcat listener on port 9999. The Netcat will start a TCP/IP socket and listens to the port for incoming connections. Once the connection is established, we can send some text using the Netcat terminal. We will be using Netcat to generate a stream of text that will be sent to the TCP/IP port. On the other side, we will create a Spark structured streaming application. The application will connect to the TCP/IP port and start reading the incoming text. After reading the text, we will apply some Spark transformations to count the words and print word count to the console. That's all. However, all of this will happen in real time. As soon as you send the data to the TCP/IP port, the Spark application will read it, count words, and print the results to the console. Make sense? Let's do it. You will need the Netcat tool for creating a listener. If you are on Linux machine, you can use the NC command. The NC command is included in most of the Linux distributions. However, I am on Windows machine, so I need to download and install something for using Netcat. I downloaded the Nmap tool for this purpose. You can get it from the following URL. Download it and install it. Once you have the Nmap tool, you can run the netcat command from the Windows command prompt. Let me show you. Start the command window or Windows PowerShell and type the following command. That's all. The listener is started. Once you have the connection on the other side, you can type some text and press enter. The text goes to the 9999 port, which your application can read. Let me close it for now and we will start it again after creating the Spark application. Great. So now we are ready to create our first Spark structured streaming application. Start your IDE and create a new project. Give a name to your project. Expand this interpreter section and select the existing interpreter. Choose the PySpark 3 interpreter, which we created in the earlier lecture. Click the create button and that's all. The IDE will create an empty project for you. This project already comes with the PySpark and you do not need anything else for creating Spark stream processing applications. However, you might want to configure Spark Log4j. You can do it using two steps. The first step is to add the Log4j properties file to your project. I already have one, which I am going to paste in this project. This file will help you control the log levels for your application. And it is the same Log4j configuration that comes as default with the Spark downloads. However, I made a small change. I changed the root log level to warn and also added this application logger at the info level. That's all. Rest all is the same as the default Spark Log4j properties template. However, your IDE is not going to pick this Log4j configuration. So you must add the given configuration to the Spark default configs. That's the second step to configure your Log4j. So I'm going to my Spark home. Then we go to the conf directory and edit the spark defaults.conf. You need to add the following line to your Spark defaults. This line will set the JVM parameter and your Spark application will look for the Log4j properties file in the current directory. Save this file and you are done. We are back to the project. Great. We are now ready to start writing some code. So let me create a Python file. A typical Spark application follows a fixed template for the main entry point. Here it is. So I created the main entry point and also created a Spark session. Now we can use this Spark session to read and process the data, right? You already know all this. If you want to use the Log4j logger, then you may have to create a Log4j class. I already have one, so let me paste it here. I created this Log4j class which pulls the logger instance from the JVM. Once you have this class, you can create a logger and use it. Let me show you. You can create a logger like this. And then using this logger will be straightforward. I'll show you in a minute. Great, we are all set. This is my first example, so I explained all the necessary steps to create the Spark project. Most of the examples in this course will follow the same steps to create a new example, and I'm not going to repeat it again. All the examples will start from this point onwards, where you will see the main method with a Spark session. Make sense? Great. Now we are ready to start writing the Spark stream processing code. Spark structured streaming application follows a 3-step process. The first step is to read a stream of data from a source. In this step, you will create a streaming data frame. You can call that initial data frame as your input data frame. The second step is to apply some transformations to process your data and create a final data frame which you want to output. You can call this final data frame as your output data frame. Finally, the third step is to write your output data frame to a sink. That's all. Let's code it and you will start getting some sense of it. So we want to create our input data frame. Let me call it the lines df. We will be reading a line of text from the TCP/IP socket, right? That's what we discussed in the beginning. How do we read it? Simple. Start with the Spark session and call the read stream method. The read stream method gives you a data stream reader. The data stream reader follows the same pattern as the data frame reader. So, just like a data frame reader, you can specify the input format, set the necessary options, and load it, right? In our case, the format is the socket. The first option is the host and the second option is the port. That's all we need. Finally, we load the data frame. This code returns the same data frame which you are already familiar with. I mean, you can apply almost all kind of data frame transformations and work with this data frame as you work in the batch processing application. However, this is a streaming data frame and some standard data frame transformations are not allowed. For example, you cannot apply a count action on this data frame. I'll talk more about what is not allowed and why it is not allowed at a later stage. But you can safely assume that most of the transformations are allowed and most of the actions are not allowed. Great. So we have a streaming data frame and you can think of this data frame reading some lines of text from a TCP/IP socket. Now, what do we want to do with this data frame? We want to transform it to get the word count, right? However, data frame transformation starts with knowing the schema of the data frame, right? What is the schema of this streaming data frame? Let's print the schema and run it. So here is the data frame schema. I have a single string field and the column name is the value. That's good to start my word count transformation. Let's come back to the code. So how do I go about it? I mean, how can we compute the word count? We can do it in 2 steps. The first step is to split the value column by white spaces to separate the words. The second step is to group the words and apply the count aggregate. That's all, right? Let me do it. I'll create one data frame for separated words. So we start with the lines data frame and use the select method. I'll take the value and split it by space character. However, the split function gives me an array of words. I don't want an array. I want each word to form a row. So I can use the explode method. The explode function will transform an array of words into rows. The explode method works like a flat map, which takes a single input and returns a bunch of rows. I hope you understand that. Great. So now my text is broken into words and it is also exploded into rows. This whole thing is an expression. So I must enclose it within the expr function. I should also give an alias to the new column. Make sense? Now we have a data frame of words. The rest is simple. I'll again start with the word data frame. Group it by words and count it. I said count action is not allowed on a streaming data frame, right? However, this count is not an action. It is an aggregate transformation. So the count aggregate is allowed on the streaming data frame. Good. So now we have an output data frame. What is next? The third step is to write your data frame to a valid sync. Writing your output data frame is as simple as writing a data frame. So we start with the output data frame and call the writeStream method. The writeStream method gives you a data stream writer. The data stream writer is similar to the data frame writer. That means we set the format, then we set some necessary options and start the write operation. We want to write to the console. So format is the console. Then we set some necessary options. The first and most important option is the checkpoint location. The value of the checkpoint location is a directory location. I am giving a new directory name in the current directory. The data stream writer will use this directory location to store the progress information. I'll talk more about the checkpoint location in the next video. But for now, let's assume that a checkpoint location is a mandatory option and data frame writer will use this directory to store some progress information about the streaming job. The next mandatory configuration is the output mode. Spark Streaming supports 3 output modes and I'll cover them in the next video. But for now, let me set the complete mode. The complete mode will show the complete output for each batch. That's all. The final step is to start the data frame writer. The start method is like an action and it will start a background Spark job. This method also returns a streaming query object. The start method is a non-blocking method that starts a background job and returns. So we must wait for the background job to complete. You can use the streaming query to wait for the background job to complete. A typical stream processing application is expected to run forever. So this await termination is not going to end until the following happens. You want to stop your application for some kind of maintenance. So you killed this streaming application. Your streaming application faced some error or exception and it terminated. In both cases, we want your application to shut down gracefully. And you can achieve it by setting a configuration for your Spark session. Let me do it. I'm adding a new configuration for the Spark session. The default value of this configuration is false and I'm setting it to true. That's all. We are good to run it. However, I'm applying a group by transformation in this example. And you know that the group by will internally cause a shuffle operation. You also know that the default shuffle partition configuration is 200. And that's a large value for this tiny and straightforward word count application. So your application might run slow because it will be unnecessarily working with 200 partitions. So let me set the Spark SQL shuffle partitions to a lower value. Great, we are done. Do you want to run it? Let me start a command window and trigger the netcat. Good. So we now have a TCP listener. Now let me run the application. Great. So we are now listening to the localhost 9999. The application runs as a micro batch and the first batch is triggered. We don't have any data yet, so you don't see any word count in the first batch. Let me send some text. Great. Do you see the word counts here? Let me send something more. Now the word count is changing, isn't it? The results are coming almost immediately, right? You can terminate your application. Do you see this checkpoint directory? This directory contains information about the progress of the current batch and some information about the previous batches. If you want to run this example, you should delete the checkpoint directory. I'll explain the reason and more details about the checkpoint location in the following video. But for now, delete it if you want to restart your application. Great, we are done with the first Spark structured streaming application. Let me summarize the main takeaways of this video. We learned the following things. How to create a starter template project for Spark streaming applications. Configuring and using application logs. We also learned the typical structure of a Spark streaming application. Creating a Spark streaming application is a 3-step process. Read the data to create your input data frame. Process and transform your input data frame to create a final output data frame. Write the output data frame to a valid streaming sink. We will learn more and elaborate it further. Great. See you again. Keep learning and keep growing.